Hello every participant, I'm Xubo Zhang from Tongji University. The main content of my presentation is Uniaxial central tearing behaviors of PVC coated fabric. My presentation consists of 4 parts, which are introduction, experiments, finite element analysis, and conclusions respectively. Here is the first part, introduction. With lightweight and unique shape design, membrane structure is widely used in the world. It is mainly employed in large stadiums, shopping malls, and some other places. However, failures of membrane structures caused by strong wind or heavy snow occur occasionally. These accidents are due to some damage in membrane materials, which can induce stress concentration and lead to tearing under overlarge snow or wind load. Therefore, the tearing strength of membrane materials has always been a hot topic. However, in different specifications, the tearing strength is just proposed as a performance parameter. Furthermore, the tearing mass and the requirements adopted in different codes are different. As for the commonly used tearing masses, they can be classified into 2 kinds. One is the out-of-plane masses, the other is the in-plane masses. The presentation here mainly focuses on Uniaxial central tearing behaviors of a PVC coated fabric. The second part is the experiment, including some basic illustration and the results. The material adopted here is a PVC coated fabric. The basic material properties in weft and weft direction are listed in the picture. The dimension of specimens is shown in Figure A. The side lengths and orientations adopted are listed in the table. The test equipment is universal testing machine, as shown in Figure B. The tensile speed is set to be 2 micrometers per minute so as to reduce dynamic effects. In order to obtain the strain distribution, the DIC equipment is employed as shown in Figure C. The representative tearing process includes 3 stages. The first is the initial stage. In the stage, the crack retains its origin shape. The second is the crack expanding stage. In the stage, the crack gradually expands with its shape changing from a straight line to an ellipse. The third is a crack propagating stage. In this stage, the crack starts to propagate, and the data zone forms. The failure occurs when the strain of the first scan at crack tip reaches the elongation at break. 2 failure modes can be classified. One is the brittle failure with no declining section on low displacement curves. The other is the progressive failure mode. The tearing strength is listed in the table. When failure occurs, the strain distribution at crack section is shown in the figure. It can be seen that the strain of the first scan at crack tip is very close to the strain at break when damage occurs. The third part is the finite element simulation. The software adopted is the Abacus Elliptic. Considering the nonlinearity of coated woven fabrics, the fabric material model is used. The inputting is the non-linear stress-strain relationship along 2 directions. As for the models, the mesh around the tip is encrypted. The load when tearing initiates is called as tearing critical load. Therefore, models based on the measuring size are established. In models, the button is the simulation and the test load displacement curves are displayed in the pictures. The curves of the samples with the same equivalent crack length are put together. It is manifested from the figures that the load displacement curves obtained by simulation are close to those obtained by tests. The curves of samples with the same equivalent crack length are almost the same, no matter in test or simulation. The stress distribution at crack section is displayed in the picture. The strain distribution obtained by DIC is converted to stress distribution through the stress-strain relationship. The theoretical stress distribution acquired by exponential stress field model is also listed. From the comparison, it can be seen that the results acquired by simulation agree well with those acquired by DIC method in most cases. As for theoretical model, stress at crack tip may deviate from the Uniaxial tensor stress, and the stress decreases slower than the test results. Finally, there are conclusions. Based on the discussions and the results in the presentation, the following conclusions can be drawn. As for tests, the tiering process can be divided into 3 stages. The failure modes of samples mainly include brutal one and the progressive one. The samples with the same equivalent crack length share similar results. As for simulation, the load displacement curves obtained by simulation are similar to those acquired by tests, and the samples with the same equivalent crack length share the same simulation results. The stress distribution at crack section acquired by simulation is also in good agreement with the test one in most cases. Thank you for your listening.